Section 7.2, we're going to review those properties of isometries. So again, moving a shape so that it doesn't change size or shape at all. We looked at translations yesterday, and also we looked at reflections. So we're going to review those rules, and then we're going to look at something called a minimal path conjecture. So the first one is review. It says transform the polygon at the right using this rule, and then write this as a vector. So go ahead and try that. See if you can remember what x plus 2 and y minus 3 means. So if you remember from yesterday, x plus 2, x is left and right, so plus 2 would mean right 2. Y minus 3 would be down 3. So you take every point, you're going to move every point right 2 and down 3. And then if you connect your line, which I should make smaller here, it'll be a translation or a slide. Remember, translation means slide. And write this as a translation vector. So remember, as a vector, use these angular brackets. 2, -3 would represent right 2 and down 3. So that is review. Also review our rules for reflection. So we'll review these. So let's say we have this original point xy. If you reflect that across the x-axis, remember the rule is you do the opposite of the y value. A reflection across the, sorry, that was a reflection across the x-axis, and the x-axis is this line right here. A reflection across the y-axis, this line right here, is almost the same. It's just the opposite of the x value, but the y value stays the same because we're flipping this way. A reflection across the line y equals x, remember that line was this line right here. And that rule was to do, or to flip the y and the x value. And a reflection through the middle point, the origin, was to do the opposite of the x value and the opposite of the y value. So here's an example. Reflect the following point, -5, 7, using the 4 rules. Okay, so here it is, the x-axis. Again, if we look at the rules, the opposite of the y value, so -5, -7. The y-axis, again, if we look at the rules, the opposite of the x value, so the opposite of -5 is 5, and we'll keep the 7 the same. A reflection across the line y equals x, you flip-flop them, so we're just going to get 7, -5. And through the origin, it'll be 5, -7. We do the opposite of each. So there's the review. Today we're going to do an investigation called finding a minimal path. Use this when you're looking for the smallest distance between things. An example is pool. It says in Chapter 1, you use a protractor to find the path of this ball. In this investigation, you'll discover some other properties of reflections that have many applications in science and engineering. They may even help your pool game. All right, so let's say you have to hit this ball. You want it to hit this ball right here. There's a cushion right here, and we need to figure out how to hit that ball so it hits the other ball. So step 1, draw a segment representing a pool table cushion near the center of a piece of patty paper. Draw 2 points A and B on one side of the segment. Okay, so they show a picture right here. Step 1. Step 2, imagine you want to hit the ball so that it bounces off the cushion and hits point B. Use your protractor to find the point C on the cushion you should aim for. So you're going to take a look at this right here, find point C. And in order to do that, you're taking a look and you're trying to find where both of the angles are equal. So you want to know when this angle equals that angle. Okay. Draw your path. And step 4, fold your patty paper and draw B prime. And what do you discover? If you unfold it, you'll mark B prime right here. It says, what do you notice? Just point C line the segment A, B prime, and it does. How does the path from A to B prime compare to the 2-part path from AC to BC? Okay, and if you measure this length is actually the same as this length plus this length. Step 6, can you draw any other path from point A to the cushion that is shorter? Why or why not? The shortest path from A to the cushion to point B is called the minimal path. Copy and complete the conjecture. So if points A and B are on one side of L, then the minimal path from point A to point L, to a line L to point B is found by, and here's what we're going to fill out. It's found by visualizing point B reflected across your mirror line. Okay, so then it says, how can this discovery help your pool game? Well, in order to hit this right here, you just have to imagine B is reflected across your cushion. So imagine this distance reflected across the line and aim for that point right there. All right, so your assignment deals with this concept right here of this minimal path conjecture where you imagine reflecting your point and aiming for that reflected point. So you can try that, and we'll go over questions tomorrow.